All right, so looking at the first four problems, let me just make sure. Okay, so a statistic and a parameter. So just remember that a statistic is based off of a sample, a subset. A parameter is a descriptive statistic for a population. So number one says 24% of vehicles sold are compact cars. So is that a parameter or statistic? Parameter, right? Because it doesn't mention a sample, it doesn't mention a mean or anything to that effect. All right, B, a sample of college students reveals 43% took calculus. Statistic, because of that word sample. C says medical researchers measured the heights of 159 males and found their mean height is 69.5 inches. Statistic, because of the word mean. That means that they had to take 159 males and they found the mean from the 159 males selected. So this is not saying that this is a population or anything. Simply because it has the word mean in it, it was taken from a sample. So that's a statistic. And then lastly, Facebook recently tested all the servers and found 90% were performing as intended. Parameter, right? It's a parameter because it says Facebook tested all of their servers. So in that case, they were able to test every population, everything in a population of all of those servers. So that would be a parameter. All right, any questions about the first one? All right, the second one, you have to tell if it's qualitative. So remember, qualitative data is categorical, and quantitative. Quantitative means you can put a number value to it. You can assign a number value. So A says product satisfaction, very satisfied, fairly satisfied, neutral, and so on. This is going to be what? Qualitative, because there is no number attached. B says neck sizes of men's shirts. Quantitative, because that shirt size has a number attached. The height in centimeters. Quantitative, because height has a number attached to it. And then the number of children. Quantitative, because you can put a number on the amount of children. Okay, now four is a little bit strange because you don't use all four. Okay, you may use some more than once. So just remember that for levels of measurement, the lowest level is nominal, and that's just categorical data. B is ordinal, and ordinal is rank order data, like grades, or specifically A, B, C, D grades. Those are in order. The satisfaction thing, highly satisfied, that's ordinal. For interval and ratio, the difference between the two is that ratio has a true zero. Zero means something. Whereas for interval, there is no true zero. So we talked about interval data, and normally when you talk about interval data, it's mainly talking about years, right? Because it technically is no year zero. That doesn't mean we didn't have a year in year zero. Zero is kind of meaningless. And also, I believe temperature, right? 0 degrees doesn't mean that there's no atmosphere outside. It just means it's cold, right? And then ratio has a true zero. Zero actually means something. All right, so what about student test scores? That would be ratio. It's not nominal because it didn't say A, B, C, D, right? So your test score can range from 0 to what? 100. So since 0 means something, that's going to be ratio because it's possible to get a 0 even though you wouldn't really want that. So A is ratio. What about B? The model year. So anytime you see this word year, that should always allude to interval ratio. All right. So remember, for interval data, zero doesn't mean anything. So when you talk about years, there is no such thing as like the year zero. All right. That doesn't mean that there wasn't a year zero. That just means that it was 0 year. All right. All right. What about C, the weight of a stone? Ratio. Because the weight of a stone could possibly be 0. Right? And what about D, the number of employees fired in last month? Well, now you can actually have 0 employees that were fired, or you could have 1 or 2. So 0 means something. So D would be ratio. Is everybody okay with that one? So just remember, for interval data, whenever you see the word year, you always want to associate that with interval data. And for ratio, 0 means something. All right. So any questions about number 3? All right, and number 4, we have to determine whether discrete or continuous. So for discrete data is finite. That's a countable set of things. So the number of people in class today is finite, because I can actually count them. Continuous data, if you recall, it was from like time and weight. Those are 2 examples of continuous data, because there are infinitely many values between 0 and 1. All right. So that's what makes the weight, and also, okay, it was weight, and what was the other one? And time. Okay, continuous. All right, so A says the number of walk buttons that work in New York City. Discrete, because you actually can count them. It might be a lot to count, but you actually can count the ones that don't work. B says the number of pets. Discrete, because you guys count the number of pets. C says weight. Weight is continuous. D says age in days. So it says in days. So can you count the number of days? So that would be discrete. Okay. All right. The first one was discrete. Okay. And D was discrete. And I think B and C were, no, B was discrete. C was the only one that was continuous. Okay. All right, any questions about the first 4? All right. All right, so those are some multiple choice type questions. Problem number 5, it deals with you constructing a frequency distribution. I think this goes back to like the second day of class when we took a data set and constructed a frequency distribution. All right, so let's take a look at number 5. Okay, so now these are actually similar to your test questions. Okay, so does anybody remember how you even start on this problem? We have to find the class width, right? So I'm going to write some steps out. One was find the class width. So I believe we had to, there was a formula. The class width is the maximum value minus the minimum value divided by the number of classes. Okay. And I believe we use a calculator. We put the data set into the calculator, we put them in order, and that better helps construct this frequency distribution. And I just hit something. There's a review sheet right there on the edge. All right, so now that I have the calculator up, we're going to take the data set and I'm going to put it into the list on the calculator. So just going back through putting data into the calculator. Okay, let me just clear everything out. In order to put this data set into the calculator, I want to hit Stat. And the first item is Edit. So I'm going to choose Edit by pressing Enter. I'm going to put my data in the list 1. So notice I already have a data set in the list 1. So to quickly clear out the data set, I'm going to go to the very top. I'm going to hit. I went to, let me just go back to the home screen. Oops. I went to Stat. And then I want to choose Edit, which is already highlighted. So I hit Enter. So now I'm into the list portion of my calculator. So you want to make sure you see list 1, 2, and list 3. Is anybody seeing anything different? All right. So to quickly clear out list 1, I'm going to go to the very top of the list. I'm going to hit Clear and Enter. Right, and that's just going to wipe out all of the numbers in the list. Okay. So now I'm going to enter in this data set. And unfortunately, there isn't an easier way to do this. And it's easy to make a mistake. 33, 18, 39, 26, 36. So once you put in your numbers, just take a minute to double check your list 40. Because if you put in the wrong numbers, you will get the wrong output. You got it? Okay, okay.
You go across with your numbers.
Well, it doesn't really matter. I went across, but it doesn't matter how you put them in. You can go up or down because we're going to put all of these in order. And then once we put them in order, this would make building the frequency distribution a lot easier than just pulling numbers from a random list.
And you put it in the descending order.
Well, it doesn't really matter. You can put it in ascending or descending. Ascending order goes from smallest to largest, and then descending order goes from largest to smallest. So it really doesn't matter, just as long as you put it in some kind of order so you kind of quickly pick out the biggest and the smallest number. All right, so once you got it in there. All right, so once you put the data in the calculator, you must return to the home screen. So I'm going to hit second and mode, which is actually the quit key. So you want to make sure that you put all your calculations or all your functions on this home screen. All right, so now that we're back at the home screen, we're going to put that list 1 in order. So I'm going to hit Stat. And I'm not going to choose Edit this time. The second and third choices, the second choice says Sort A, and that's ascending order. So it's going to put it in order from the smallest to the largest. Sort D is descending order, and it puts the number in order from the largest to the smallest. So I'm just going to choose sort A. So once I hit enter, this is why you want to be on your home screen, is because it's going to put that function on the previous screen that you were on. So if you were like still in that list thing, it'll put the sort in the list. All right, you got it? Okay, yeah, you got an 84 plus, so you ain't made it really different. So I think what it did was, and now you want to put in this one. So I'm going to show how to do it. Well, I went to the home screen and I just said, right, in mode, and I just cleared it out. That's right. That's right. All right, so now if you hit and go down to section. All right, so once you have sort A, you want to put in the list in which you want to sort. So we want to sort list 1. And since list 1 is yellow, I'm going to hit second and the number 1, and notice it pops up L1, which is list 1. And now if I close my sort function, and if I hit enter, it appears as though it hadn't done anything, right? It just says done. But if I go, right, just hit enter. And now if I go back into my list, so if I go back in the stat and I want to edit the list, so I'm going to hit enter. Notice that it puts those numbers in ascending order. So we're not just looking at random numbers. The smallest number is 15, and if I scroll down, the biggest number is 43, right? So is everybody okay with putting the data into the calculator and then sorting it? All right. So now once we've sorted it, this makes life a little bit easier. So now we can calculate the class width. So we got to take the maximum value, which is 43, right? Minus the smallest value, which is 15, right? So my smallest value is 15. And then we have to divide by 6, right? Because 6 is the number of classes. So 43 minus 15, that's going to give us 28 divided by 6. So 28 divided by 6 gives us 4.667. And we have to do what? Round it up to the next highest integer. So our class width is 5. Right. So is everybody okay with that? Even though we got 4.667, you always round it up to the next integer. So even let's say if we would have got an even value like 10, you would still have to move that 10 up to 11. Right. So 5 is the class width. So is everybody okay with the class width? So now let's lay out the intervals. So I'm going to start with my smallest number Let me just write this out. This is the classes, and I think we have to find the frequency. And I believe that's it for this problem. Let me just double check.
You said even if we're saying we round up to that, right?
That's right. That's right. You always round up to the next integer. Okay, yeah, it just wants the class and the frequency. All right, so in order to lay out my classes, I'm going to start with my smallest number, which is 15, right? And since the class width is 5, remember you find the class width by subtracting consecutive lower limits or consecutive upper limits. So if I were to add 5 to 15, that's going to give me what? 20. And 20 is the start of the next class. What's that? Okay. You okay with what's going on? Okay. So now I can add 5 more to get what? 25, 30. Can I add another class? 35, because we have some numbers greater than 35. And then if I add 5 again, I get 40. If I add 5 again, I get 45, but that's going to do what? That's outside of our numbers here. So I'm going to stop at 40. So we have all of the lower class limits. So now we're going to write out the upper class limits. Right. So if the second class starts at 20, that means the previous class has to end at what? 19. So that's like 19, 24. Right. So basically I'm taking the lower class limit and I'm subtracting 1, and that's going to give me the upper class limit for the previous class. So then I think this is going to be 29, 34, 39. And what is my last upper limit? 44. Because the class width is 5. So if I add 5 to 39, we get 44. All right. So is everybody okay so far? So now all we got to do is put in the frequencies. So in order to write the frequencies or counts, I'm going to go back to the data set. So I'm going to hit stat and I'm going to hit enter. And that's going to put us inside of our list. And now I need to count the number of numbers between 15 and 19, including 15 and including 19. So that's how many numbers? 1, 2, 3, 4. It looks like there's 4 numbers that range between 15 and 19, including 15 and 19. So the frequency for that class is 4. Is everybody okay with 4? Because you have to include 15 and 19. All right. How many numbers are in the next class, 20 to 24? Looks like 2, just 20 and 24. Okay. How many numbers are between 25 and 29? Looks like 3. How many numbers between 30 and 34? Looks like 3 again, right? 35 and 39. 1, 2, 3, 5, right? 1, 2, 3, 4, 5. Because you have to include 35 and 39. So that's 5. And how many numbers in the last class? Looks like 2. Is it 3?
Yeah.
Yeah, it's 3. 40, 41, and 43. So that's 3. And that is the frequency distribution. Any questions about number 5? So just a key thing, when you find that class width, you always have to bump it up by 1, no matter what that number is. Then we use the class width to lay out the lower class limits, right? We started with the smallest number in the list, and we just added 5. That gave us all of the lower class limits. To find the upper class limits, I basically just subtracted 1 from the lower class limit, and that gave me the upper limit for that previous class. And then in order to find the last upper limit, I used the class width and I added it to 39, and that gave me the last number in our frequency distribution, which is 44.
On the upper class limit, you can add 5 to all of them as well.
That's right. From 9, you can just keep adding 5 all the way down. That's right. All right, now number 6. This deals with a frequency distribution. So here they give us the actual classes. They give us the frequencies. We have to find the midpoint. So the midpoint that's the lower limit plus the upper limit divided by 2. There's a formula for that. The relative frequency, we have to divide the frequency for the class by the total frequency. And then the cumulative frequency is the frequency of that class and all classes prior. Right. So we're going to fill out the frequency distribution. All right, so first let's find the midpoint. Okay, so in order to find the midpoint for every class, we're going to basically add the upper limit, the lower limit, and divide by 2. So for the first class, its midpoint is 180 plus 193. That's 373. And I'm going to divide that by 2. That's 186.5. Now I can do that for every class, or I could figure out the class width, and I could just repeatedly add the class width. So what is the class width for this distribution?
14.
Should be 14, right? Because if I subtract consecutive lower limits, right? 194 minus 180 is 14. So once I find that first midpoint, I can just continue to do what? Add 14, right? So if I add 14.
194 minus 207 is 14.
Right. Plus 14 again is 214.5. Plus 14 again is 228.5. And 14 again is 242.5. All right, so those are all of the midpoints. Now we have to find the relative frequency. So in order to find the relative frequency, it's the class frequency divided by the total frequency. So what's the total frequency? Well, I have to add up 3 plus 7 plus 2 plus 12 plus 8, right? Just add up all of our counts, and we get 32, right? That's the total frequency. $32. So now I'm going to use that in my denominator as far as my relative frequency is concerned. So if I were to find a relative frequency for my first class, I'm going to take the frequency for that class, which is 3, and I'm going to divide by 32. So 3 divided by 32 is 0.09375. It says they should be in decimals rounded to 3 places. So if we round at the 3 places, I believe it's 0.094. 0.094. For the second class, its relative frequency is going to be the frequency for its class, which is 7, divided by the total frequency of 32. 7 divided by 32 is 0.219. The frequency for the third class, well, the relative frequency for the third class is its class frequency, which is 2, divided by the total frequency of 32. So 2 divided by 32 is 0.063. The next to the last class relative frequency is 12 divided by 32. Which is 0.375. And then the last class's relative frequency is its class frequency of 8 divided by the total frequency of 32, which is 0.25. All right, so any questions about the relative frequency? Okay. All right, so now if we take a look at the cumulative frequency, and there is a definition for the cumulative frequency. It's the frequency of the class and all classes prior. Sorry about my hand, right? This desk has a big hole in it. All right, so it's the frequency of that of the class and all classes before it. So the cumulative frequency for the first class is just 3, right? Because that's the frequency of that class, and there's no classes before it. The cumulative frequency for the second class is 7, but you have to add the classes prior, so I have to add the 3. So 7 plus 3 is 10. The cumulative frequency for the third class is going to be what? 2, but I got to add the 3 and the 7. So that's going to give us 12, right? Everybody see what I'm doing? The cumulative frequency for the next class 24. And then the cumulative frequency for the last class should be what? 32. So the cumulative frequency is the frequency for that class and all classes prior or before. All right, so any questions at problem number 6? Now this thing carries like 12 points. And then problem number 5 carries 12 points. So these are two questions that are really big as far as the grade is concerned. All right, any questions about 5 or 6? All right, now if we move along to number 7, it deals with a stem and a leaf plot. And it says, here is the data summarized as a stem and leaf plot. So they give us a key at the bottom. And the key says that the first number is the stem. So these are like 2-digit numbers. So like this 4, and then you see this little vertical bar and 5, that represents 45. So if I look at my stem and leaf plot, this first row actually contains 3 numbers, which should be 62, 65, and 68. That second row contains 6 numbers, which are 71, 73, 74, 77, 78, and another 78. The next row contains 4 numbers, 82, 85, 86, and 87. And the last row contains 2 points, 96 and 99. How many data values are in this data set? Should be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let me just copy it so I can write on it. All right, so there's 15 numbers in the data set. What is the minimum value for, what is the minimum value in the last data, in the last class? Should be 96, right? So that's 15. That's 96. Because in my last class, there's 2 numbers, right? 96 and 99. The smallest is 96. And then the last question says, how many of the original values are greater than or equal to 70? Right. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. All right. So how many of the original values are greater than or equal to 70? Should be 12. And then the last one says, what percent of the values are greater than or equal to 70? All right, so for that one, and normally I would do this before class. Okay. So how many values are greater than or equal to 70? That was what? 15? No, it was 12. Okay. Now I'm going to use that for my last problem. It says, what percent of the values are greater than or equal to 70? It says, what percent? So I have to take the number of numbers that are greater than 70, which is 12, and I have to divide by all of the numbers in my data set. So there's 12 numbers that are greater than or equal to 70. How many numbers in this data set? 15. So if we divide 12 by 15, we get 0.8. What is 0.8 as a percent? 80%. So 80% of the values are greater than or equal to 70.
Where do we get our 12 from?
12, this comes from the numbers greater than or equal, to 70. Right. So we had to use a prior result. Okay. All right. Any questions about number 7? And this has like 6 points. All right, going down number 8. It says the following dot plot. I don't even think I talked about a dot plot, but it says the following dot plot outlines the results of a set of scores on a standardized exam. The first one says how many data items exist in the data set. B says find the mode of the data set. C says what percentage of values are greater than or, what percent of values are greater than 30? Answer with a whole number percent. So first off, how many numbers are in the data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Should be 18. So how you actually read this, it means that for a standardized score of 25, there were like 2 people that scored 25. For 26, there was only 1 person. For 27, there was only 1 person. For 28, there were 2 people, and so on and so forth. So if you count up all of those numbers in the data set, you should get 18, right? What is the mode of the data set? 30. So remember, the mode is the number that appears the most. So that's 30. Okay, let me just copy this over so I can write on it. Come on. All right, so there's 18 numbers in the data set. The mode is 30. The last one says what percent of values are greater than 30? So now, since this doesn't say greater than or equal to, I'm not going to count what's at 30. I got to count the numbers that are more than 30. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers, right? Greater than 30. That's right. We can't count 30 because there is no equal to. And how many numbers are in the data set? 18. So 8 divided by 18 is 0.444. And if you had to change that to a whole number percent, it would be what? 44%.
So it was 0.445.
Well, so like for 0.444, if I wanted to change that to a percent, I would move the decimal 2 places to the right. So I get like 44.4%. And then if I round this to a whole number percent, if I look to one place after the decimal, I got a 4. Since it's not a 5 or greater, I'm going to leave this as 44%. Okay. All right, so that should be 44%. All right, any questions about number 8? Okay, going down for problem number 9. And I really don't like this problem number 9 because it doesn't like line up evenly with the number graph or whatever. But this one said we're given a box plot, and it says based on the box plot, I identified a 5 number summary, which is the minimum, Q1, Q2, Q3, the maximum. So if I look at my box plot, the minimum value is going to be here. which should be about what, 7? I looked at the answer key because I'm like, is that 6? So it should be 7. Okay, Q1. That looks like about 17, right? The median looks like about 21, right? Q3 is about 37, and then the maximum is 40. So it's a little bit subjective when you're looking at that. Like, my eyes are bad, so that can look like almost anything. All right, but any questions about number 9? Yeah, let me copy this down so I can write the answers on here. All right, so the minimum looks like it's about 7. Q1 looks like about 17. Huh? Oh, this is the minimum. This vertical line is Q1. That vertical line is Q2. That's Q3. And that's the max. All right. So the median looks like about 21. Q3 is about 37. And then the max is 40. All right, so each vertical line in that box plot, it represents the minimum, Q1, Q2, Q3, and the maximum. Okay. All right, so that was number 9, and that's worth 5 points. All right, problem number 10, it says, in your pre-calculus course, your final grade is based on 4 categories. The categories are tests, lab, homework assignments, and a final exam. The final average for the course is a weighted average of scores earned in these categories. So the tests are worth 38%, labs are worth 12%, homework is 14%, the final exam is 36%. Those are all of the weights. Right. Suppose you earn the following grades: a 58 on tests, an 88 on labs, 95 on homework, and a 90 on the final exam. Determine your weighted average in the course. Now, this is a little bit different from that GPA calculation and the daily balance carried forward. All right. So just to show the difference on this, and I'm going to lay this out in some columns and some rows. So this was number 10. All right, so this is number 10. So I'm going to write this out as the grade I'm going to write it out: the class, the grade, and then the weight. And then there's another column. So first I'm going to start off with the test. Well, I should say assignments. Excuse me. So this would be the test, the labs, the homework, and the final exam. All right. So I have all the assignments, tests, labs, homework, and the final exam. So if I look at my grades, it says the following grades were earned. There was a 58 on the test. Right? So the test grade was a 58. There was an 88 on the labs. There was a 95 on the homework and a 90 on the final exam. Right? So those are all of the grades. Then we have our weights. So the weights for the test is 38%. I'm going to write that percent as a decimal, 0.38. The weights for the lab is 12%, so I'm going to write that as 0.12. The weights for the homework is 14%, so 14% as a decimal is 0.14. And the final exam weight was 36%, which is 0.36. Right, so we just kind of mapped everything out. So now in order to determine the grade, I'm going to multiply the grade times its weight. So 58 times 0.38 is 22.04. 88 times 0.12, which is 12%, is 10.56. 95 times 0.14 is 13.3. And 90 times 0.36 is 32.4. So keep in mind now, this is not a GPA calculation. This is a calculation, let's say like for this class. So there was like a homework percentage, a quiz percentage, a test, and it was something else too. It was 4 categories. So you would take your average or your grade for each, you multiply by the weight. Now, in order to determine the grade, I'm simply going to add all of these up together. Now, in the GPA calculation, we kind of added it up and divided by something. Since this is a class grade calculation, we're going to add all of these up, 22.04 plus 10.56 plus 13.3 plus 32.4, and we get 78.3 for the final average. So now keep in mind on this answer, on this sheet, there is a key at the back. All right, but the key is only going to get an answer. It's not going to show how you derive the answer. The final grade will be 78.3. The weights come from, I'm sorry, they're up here. I just changed the percentages to decimals. And then I multiplied the grade times the weight and just added up all of the grade times weights numbers. So any questions about number 10? It's a little bit different than what we did in class, the GPA calculation. All right. So number 10, that was worth 4 points. Okay, number 11, I'm given a list of numbers and we're actually finding the mean, median, mode, range, standard deviation, and variance. So I'm basically going to put this in a list and do the one variable statistics. And that'll give me most of these things. All right, so I'm going to put this data into the calculator. Okay, I'm going to put it in list one, right? So I hit stat. I want to choose edit, so I'm going to hit enter. I'm going to clear out the numbers in list one. And we're going to put in these 8 data values. What is going on? $30, $31. Okay, so 20, 20, 19, 35, 22, 25, 31. Okay, so I have all of the items in list one. I'm going to return to my home screen. I'm going to hit stat. I'm going to scroll over to calculate, and we want one variable statistics. So if you have a TI-84, and I think this looks the same for 83 or 84. I want to make sure I put in list one, right? One variable statistics for list one, and if I hit enter, it gives us the mean, which is X bar. Okay, let me just copy this over really quick. All right, so the mean is X bar, that's 25.25. Or it says round in one decimal place, so that'll be 25.3. The median is also known as Q2, right? So if I scroll down on my list of output, it gives us that the median, which is Q2, is 23.5. And I can also pull out the standard deviation. So since this is a sample standard deviation, I'm going to look for that S sub X value. So I think I got to scroll up. So my S sub X, remember this is the sample standard deviation. This sigma sub X is the population standard deviation. So what I'm looking for in this sample is the S sub X value, and that should be 6. It should be 6. It says round in one decimal place, so that's going to be 6. And then that's about all I can pull from the one variable statistics. The mode of the data set is going to be what? 20, right? I can kind of look at that and tell. The mode is 20. What's my range? Right? So the range is the max value minus the smallest value. So the biggest value in this data set is 35. The smallest is 19. Okay, so 35 minus 19 is 20, no, 16. Okay, should be 16. How do I find the variance? It's the square. So if I take the standard deviation, which we just found is 6, and if I square that, I'm going to get what? 36. Now here's another way I can find it with the calculator. If I go into list, I want to hit second in stat, which is list. I can scroll over to OPS as operations. I can scroll over to math. And now if I wanted to find each one of these things separately, I could. I mean, I could find the mean, I could find the median, I can find the standard deviation. But there's also this variance key.
You have to get rid of that.
That's right. I was at my home screen, right? And then I went into list, which was second in stat. I scroll over to math, and variance is that last function. So I want to find the variance from list 1. So if I put in list 1, it should give us. Now, if you take a look on the answer key, they give you 2 answers for the variance. One says 36 and one says 36.5. So they will give you credit. Let me just make sure. Yeah, if you take a look at the answer key for problem number 11, notice it gives you the variance could either be 36.5 or 36. So if you calculate it manually based on the standard deviation that was in the one variable statistics, you can just square that. That gives you 36. But if you use this variance formula, notice it gives you 36.5. So they kind of account for both of those. All right, any questions about number 11? All right, number 12. And it says this is worth 2 points. Every year, the students at the school are given a musical aptitude test that rates them from 0 to 5. 0 is no musical aptitude. 5 is the highest musical aptitude. And here are the results given for this year's results. So we have the amplitude score, and we had a frequency. It wants us to calculate the sample standard deviation for the data using 2 decimals. So what we want to do here is we're going to put the aptitude score in list 1. We're going to put the frequency in list 2. So I don't have to find any midpoints or anything because they've just given us an aptitude score 0 through 5. So once we put them in L1 and L2, we're going to use a one variable statistics, and that's going to pull out the sample standard deviation. All right, so let me just copy this over really quick. All right, so we're going to put L1 as the aptitude score. That's 0, 1, 2, 3, 4, 5. L2, those are the frequencies, 0, 2, 3, 3, 5, 3, and 10. So I'm at my home screen. I'm going to go into second in mode, which is that quick key. I'm going to hit stat, and I want to choose edit, so I'm going to hit enter. I'm going to use the first 2 lists, so I'm going to clear out list 1 and list 2. So I'm simply going to go to the top of the list. I'm going to hit clear and enter. Okay. I'm going to put in the aptitude scores for list 1 and the frequency for list 2. So not a lot of data to enter here, just putting it in the right way. So list 1 is the aptitude score, list 2 is the frequency. I'm going to return to the home screen. And now in order to calculate the sample standard deviation, I'm going to hit statistic. I want to scroll over to calculate. I want to choose one variable, statistics. Since I'm dealing with 2 columns of data, I have to tell it list 1, comma, list 2. But I believe you have a TI-84, it says X list and like frequency list, right? So for your X list, you want to put in list 1. For frequency list, put in L2. And then you want to calculate. But here I'm just going to hit enter. All right, and we are asked for the sample standard deviation. So we're going to look for S sub X. And if we round to 2 decimal places, I believe that should be 1.4. Right. So that's the only thing it's asking for, that is to find the sample standard deviation. All right, any questions about number 11, number 12? All right, number 13, it says calculate the frequency, calculate the following for the given frequency distribution. So we're given this frequency distribution. This asks for the population mean and the population standard deviation. So now, unlike the previous problem, right, for our classes or our aptitude score, we just had one single value. But for this one, we have a class range. So in order to find the mean and the standard deviation for this, we're going to have to find the midpoint. All right. So I'm just going to draw some extras. So we're going to have to find the midpoint. And then once we find the midpoint, we're going to have to treat the midpoint as L1. We'll treat the frequency as L2. We'll go back and calculate that one variable statistic. All right, so how do I find the midpoint for the first class? Well, remember that form, I can just add up my lower and upper class limit and divide by 2. So 30 plus 38 is 68. Divide that by 2, we should get 34, right? How can I find my other midpoints? I can add the class width, which is 9, right? Is everybody okay with that? So in order to find the class width, 39 minus 30 is 9. So I can add 9 to my midpoint, and that's going to give me the midpoint for the next class. So 34 plus 9 is 43. If I add 9 again, 52. If I add 9 again, that's 61. If I add 9 again, I get 70. And if I add 9 again, I get 79. Is everybody okay with the midpoint? So now once you find the midpoint, I'm going to put the midpoint in as list 1, the frequency in as list 2, and then we're going to use that same one variable statistic. So I'm going to clear out the numbers in my list. And you want to make sure you specifically put the midpoint in list 1 and the frequencies in list 2. So I believe I have everything 34, 43, 52, 61. Okay. All right. So once you put in the midpoint as list 1 and the frequency is list 2, I'm going to return to my home screen. I want to go back into stat. I want to scroll over to calculate. The one variable statistics, L1, L2. So now the population mean and the sample mean are both X bar. So that's going to be 52.31, right, rounded to 2 decimal places. Since we're asked for the population standard deviation, you want to use the sigma sub x value. So if we round that to the nearest 2 decimal places, I believe that's 14.57. Any questions about number 13? I'm just looking at the time, 14. Okay, I'll do a video that works out 14. I think everybody should be okay with 18. I'll work out a video for 14 through 16. All right, I think everybody's okay with 17. And then the last one, problem number 18, there is a video on the home page that kind of works out 18. Okay, yeah, I'll do a video for these last few problems. We're running out of time. All right, so you have the answer key. Okay, and I'll make the video for the last few problems or so, just so everybody can have that. I am also recording